Hello, hello. Testing, testing, 1, 2, 3. Hello, hello. Testing, testing, 1, 2, 3. Hello, hello. Testing, testing, 1, 2, 3. Hello, hello. Okay, sweet. So, testing, testing, 1, 2, 3.
I'm live.
Hello, hello. Okay, sweet. So, testing, testing, 1, 2, 3.
I'm live.
Hello, hello.
And this. I want to check that it works. So it looks not the best quality. Check that it works. But this is not bad. Cool. Not the best quality. Check. Not the best quality. Check. Not the best quality. Check. Okay, that's funny. I'm streaming my stream. So it looks like that's the link. And okay, cool. So first, let me get my yerba mate. Very good stuff. Solid. Let's see. All right, so we are going to be solving this puzzle here, beside the point by Jane Street. But basically, instead of trying to solve it mathematically, we're just gonna try like a brute force approach to try and get like an approximate answer using just like Python code. So to kind of get people up to speed, so you have a box, and what you do is you pick two random points, one red and one blue. You choose them uniformly, so they can like be anywhere, and like every position has an equal probability, and independently from one another, so it doesn't matter like where one or the other is. Um, and then what you do is um, you find the side that's closest to the blue point, and then it's indicated with blue in these images. And then you basically see if there is a point on that line that's equidistant from the red and the blue point. So that means that basically that like you can draw a line like this, you can draw a line like this, and they're the same length line. And then in some cases that's possible, and then in some cases like here that's impossible because like anywhere you pick on this line, the blue point's just gonna be closer. And same here, here, and here. And so what you need to do is you need to find the probability that there exists a point on the side of the square closest to the blue point that is equidistant to both the blue point and the red point. Basically, we need to like randomly pick these points and then see what the probability is that there is a point that's equidistant to both. Um, so yeah. Um, so the math here gets pretty tricky, but like today I'm gonna try to just brute force this. So let's open PyCharm and see what we can do here. All right. So old stuff I was working, but let's make a new file. Call it. Okay, so let's see. Sort random. That'll be the first step. So we need to think through. The first thing is you just need to like pick 2 points. Now, I think there's an argument to be made that you only need to randomly pick 1 point because like maybe it doesn't matter like where your first point is because like 1 point is gonna like the other point is basically just gonna decide it, but I don't know how true that is. So I think I'm gonna start out by just like picking both points randomly. Um, and let's see, we can say that the coordinates are just between 0 and 1 maybe. So let's see. Pick point, and we need, I think it's random.rand. Yeah, I think, okay, random.random. Is that uniform? Yeah, returns a random floating number between 0 and... Is this uniform though? Because we can't have like, we can't have a standard deviation. Like we need it to be equally probable. Yeah, any value within the interval has an equal probability of being... Okay, so it is a uniform. Cool, cool. All right, so just return random.random random. Okay, so pick point will basically just give us random x and y on this. Okay, cool. So we get a random x and a random y, and then we can call it twice to get our both of our points. So now what do we want to do? We can define like a single trial, and then what we do is we say call it blue equals blue equals pick point, and red equals pick point. Okay. Now we have 2 points. Now I guess what we have to do is just we have to decide we have to determine if there's an equidistant point or not. Because the question is like how do you figure that out? Like we might need some. I wish I had my little drawing tablet. Could draw with a pen instead of my mouse, but for now this will work. Like we pick a point here, or maybe that's a bad. But let's say it's just, why is this? So then like we can determine the side that's closest. Now technically what we could even do is we could get this square that we have. We could like split it into 4. Because really like it's symmetrical. Like if we pick a point here, that's really the same as like picking a point here. And I would argue that you can even split it more. Like I think you can probably split this in half as well, because I think this. And then you really only need to look at like one of these triangles, because for the rest it's gonna be the same exact thing. Like it's completely mirrored. Um, which is hmm. I wonder if we did that, we wouldn't have to have the calculation that like tells us which side is closest, which would make it a little bit faster and simpler, I think. Um, but let's see. Hmm. I mean, what are the dimensions of this? This is 0.5. And then we know that this point is, this is 0.5 as 1. Hmm. And then, I mean, this is just a 45-degree angle. We could say pick a point anywhere in the triangle. I don't know. I think there's a chance to like make some sort of error mistake here. I think it's safer to just go like with the full square, you know? Um, okay, so I guess the next thing would be we have our 2 points, right? We have our square, we have our A. Now we need to tell if on the, well, let me not column A, B and R, blue and red. That's what. And we need to figure out which side is closest to B, and then whether there's a point on that side that's equidistant from blue. Hmm. We're working with floats, so like it's a little bit tricky. We have to be a little bit careful with like the precision we use. Hmm. Okay. So I mean, okay, first maybe we can try to tell like which side is closest to blue. I guess how would we do that? So we could say that this is side 1, and then we could just make like simple ranges depending on like the x and y coordinates. So, for example, So first we just take the, I guess we would, maybe what we do is we, like let's say x is 0.3, y is 0.7. We can do like 1 minus x, 1 minus y, whichever is smaller. No, we need, so whichever is further from 0.5. So we either need how close it is to here or how close it is to here, and then compare that to this and this. And we just take the minimum value, and that minimum value decides what side is close. Okay. I guess what we could do is there's I know there's like there has to be like a very right, maybe like it's 0.5 minus 5 minus y, take like the absolute value of whatever is greatest, because like if we have 0.5 minus 0.9, it's going to be a very large number. If we have 0.5 minus 0.1, again going to be pretty high. And then if we have like 0.1 minus 0.33, that's not that high. 0.5 minus 0.44, even lower. So yeah, the higher the number, the higher the absolute value of the number. So I guess what we can do, we can say also like, I don't know, do we just define these sides with numbers? Like we just say this is 1, 2, 3, this is 0, 0. I think that should work. Okay, so have equals, okay, so that won't give us the exact side though, because we did absolute value, so we lost some. So maybe maybe we'll just do xd1 is just xd1 minus. So in this case, okay, in this case we have where picked a point, call this d1, d2, or xd. And you know what, actually we can, since we're calling this 1, 2, 3, 4, maybe a better naming convention is just to say that this is d1, this here is d2, this is d3, and then whichever is smallest, that's the side. So okay, so d1 equals, that's just the x value, d2 will be, wait, no, stupid, this is 0, 0, that's the y value, um And maybe we do blue X, blue Y, red X, red, like that. So D1 is just blue Y, and then D2 is gonna be 1 minus blue X equals 1 minus blue X. D3, this is 1 minus blue Y, and then 4 equals blue X. Okay. And then okay. Oh, sorry. I missed the chat. Check when BTRL bottom, top, right, left for. Okay. Dude, I was not I was not paying attention. Bottom, top. Do we wanna bottom, top, right, left? Well, okay. Let me reframe here. So bottom, top, right. Okay, make this 0. Is that I made this 0 0 because that's how like computer graphics. Usually you have 0 0 here. This is 1 1. But in math like this makes. I think that's right. Okay, so then we can say distance bottom is just the y value. Distance left is just the x value. Distance right is 1 minus the x value. And distance top 1 minus the y value. And we bottom, top, right, left. Bottom, top, right, left. Okay. Okay. And then okay, we need to say closest side in let's run it like oh okay. Yeah, okay. So we have the minimum distance. Okay, now we need to like figure out, so we have our blue point. we have our red point. And we know the distance from the blue point to the closest. And now we need to decide. So I guess we need like a, how do we notate these sides in code? So this is, I guess we can call, like, each side is technically a range, right? So this, like, this side is, it's 0, 0 to 1, 0. So this is a bad variable, but we can say like, this is not very good, but let's hear me out. So we just check if this is the closest side, and then we need a variable like what should our variable range? So this is bottom 0, 0. Right, because that's top. It's D right. Side range. So if it's bottom, it's 0, 0 to 0 to 1, 0. If it's top, it's 0, 1 to 1, 1. And then if it's right, it will be 1, 0 to 1, 1. And then if it's left, then it'll be, if it's left, then it'll be 0, 0 to 0. 0, 0 to 0, 1. Okay. So this is our point, 0.69, like around here, and then 0.2. And then this is the distance, and it's 0, 0, 1, 0. Okay, let's test another. Okay, 0.27, so here, 0.4, so here, and then this is our closest side. Okay, yeah. 1, 4, 8, and 2, 3. So here, this one again. That right? Wait, 0, very small x, like here, 0, 0 to 0, 1. Okay, that's right. I just want to get all the sides. So 0, 3, 2, and 0, 6, 7. And then it's saying this is the closest. 0, 1 to 1, 1. Is this, what's 1 minus 0, 3, 2? Because that's, okay, those are really close. Okay, but that's right. I want to get the, oh, 0, I want to get the 1, 0, 1, 1. Oh wait, we're not. Okay, there you go. So 0, 8, 3, 0 0.8. It's like here. This is perfect. So we know okay. We know what the range of coordinates of the closest side to it is. Now hold on. I'll be right back. Alrighty, tidy. I'm back. Let's see. So to recap here, we have our problem, and we're able to get the range of coordinates of the closest side. Now the next step is we need to tell if the red and blue dot have an equidistant point that side. So how would we do that? Okay, so I have an assumption here. I don't know if it's true, but I have a feeling that if hear me out, if the red point is further than the blue point from the side, then it's gonna be the shortest possible distance for the red point for them to be equidistant. And then if the red point is closer, the red point is closer than the blue point. I don't know. I don't think that's true. It's like in this example here, this would be I mean I think Like this would be the closest, but it doesn't work for. Maybe that's not true. I guess another way is you could say, well, there a center circle on here where the arc goes through both of these. But I don't know if that's any simpler to code up. Because that actually seems a little, but hmm. So I guess like what? Okay, I'm gonna give this like 5 minutes thought. If I don't come up with something in 5 minutes, then I want to ask Grok for help here. Okay, so 311. By 311, if you don't have a good answer, then it's gonna be time to ask. Now, if I was doing this for speed, I'd ask Grok right away. But I'm also doing this for fun, so I want to give it a little bit of thought. But I mean, let's think about it, right? We need to find. Okay, I mean, here's one point. No matter where your points are, if your side is infinitely long, then you'll always. I guess, is that? What if you have like this, like on this line, if it's infinitely long, there's still never a point that's equidistant, because this is just closer than this, right? Like there's no way you can have. So doing that assumption, then what's the way to tell? What's the way to tell? The way to tell if there is or there isn't with this. So if I think so. I gave this problem to a recent PhD grad who I just happened to meet at my school, and so he kept talking about perpendicular bisectors. And I think what he means by that is if you draw a line here, then through this line you can draw a perpendicular bisector. Which basically all that means is that it's in the middle of this line and it's perpendicular. And if this perpendicular bisector crosses the closest side, then that means that's your equidistant point. I'm getting some advice from Discord. Okay, so that's actually the same exact idea having. But yeah, so you take um you take the perpendicular bisector, and if the perpendicular bisector crosses this side, that's your equidistant. Now, let me just check real quick. Like for example, if you have this point, perpendicular bisector would go like this, right? And it never ever crosses that side. Okay, nice. So, and then one more thing is if you could have a situation where like have maybe this is here, this is here, and this is our blue point. So this is our closest side. If you have a perpendicular bisector like that, it would go here. It does eventually cross this side right here, but that's outside the box. So we kind of have three situations, right? Like crosses in within the range, it crosses outside the range, and then it just like never crosses at all. So let me see. By the way, I want to show you guys what I got from. Okay, I think the best way to check for any two individual points is to create a line between the 2 points, create a point in the middle of the 2 points, then make a line crossing through the new point and orthogonal to the line between the points, then see if that line crosses the line segment of the. Okay, exactly. Yep. So that is what we're going for here. So if we have these 2 points, we can know the line between them. Like we could figure out the equation of the line between them. So and then we could figure out the midpoint, and then the perpendicular bisector would be like if the slope here is m, the slope would be negative m. I think that's the definition of orthogonal, right? Like if you have y equals 2x negative 1, yeah, so it's negative 1 over m is the definition of orthogonal, which means crossing, there's a 90-degree angle. So, okay. And then after we have this, we have the equation of this line. We can well, we know for it to cross, it has to be either for it to cross, so we know either the x or y values. Like if it crosses left, we know that x has to be 0. If it crosses top, we know y has to. So we just have to plug in that value into this equation, use it to derive the other value, and then check if that other value is in the range. I think it's that simple. Okay, so let's see. Let's get the midpoint. So midpoint is just the average of it's blue x plus red x mid x mid y equals y divided by divided by 2. So if we have a point like 10, 5, then the midpoint would be 5. That look right? Then if we had a point like 10, 3, 5, 9, then the midpoint would be 5. And because it's the same distance, right? Because it's from the y and it's 0.5. For some reason, this yeah, okay, that's right. Okay, so we have our midpoint. Now we need our slope. So our slope of what would that be? Well, I guess we can just calculate. So y minus y, y2 y minus divided by x minus divided by. Okay, okay, nice. Okay, and then we need to get the slope. So the slope m, what will that be? We just need to move these. And then we need to just get y. We need to separate. We need to get just x. Okay, but we don't need the rest, right? We just only x. So m equals, well, that's a little embarrassing. That shouldn't have I like pretty common, right? Um because m 3 minus, and then so we have the midpoint. We have m. We need the equation of the perpendicular bisector. So let's see. Hmm. Equation of perpendicular bisector. Y equals, our point is centered, then y minus. Okay, there you go. Perfect. So with these 2 points, This is the line between them. This is the midpoint. Then perpendicular bisect. So okay. So let's get our slope. And then give me another. Be right back. Got myself some water. Back. So we've got this is the equation for perpendicular bisect. And then we basically need to either find x or the y based on the side that we have. So maybe we can define two functions. Like y of x on micros negative reciprocal. we are solving this in terms of x. Divided by a same exact. Perfect. So it would be I divided by Pythagoras. Okay. So I think we're getting pretty close to having the core done here. So now we just need to see which variable we know versus we know the closest side. So in this case, like if it's a bottom, then y is always 0. So we can plug in y, find the x. If it's a top, then y is always 1. So we can plug in y1, find the x. The x is inside this range. Have a equidistant point. If not, then we now, and then if it's right, then x is always 1. We plug in x to find the y. And then otherwise it is. So what do we range? We need to know the value of the variable that stays. So maybe we'll call it like x, y. Right? Because x is constant, y is constant, y is constant. Okay. So now we have now what we need to do basically. If constants, if x is the constant, x is constant, then we can I'm gonna comment. You know that the other y of instead of x. Okay, okay. What we can even do is we can even check this with Desmos if we print our negative. Okay. Okay. So go on Desmos. So this is hold on. Peace about that. That's our point. And then this is and then these are our 2 points. Hold on. I realize you can't. You can see my Anyway, here's our square. Sorry about that, guys. I just had some. So we have our square, and then the closest side, 0, 1. Y minus this value. Hey, our perpendicular bisector right here. There you go. So, looks right. Saying there is no solution. Okay. Oh, so I kind of want to draw this. Okay, so what I'm gonna do is I'm gonna prompt Grok to make the Pygame for this, if it can. Alright, let's let Grok think about this. Okay, Grok is still thinking. Um, taking a while. Been 90 seconds now. Because I guess it needs to think through the geometry. I'm actually interested how well it does. If it one-shots it, I'm gonna be pretty impressed. And I mean, I think my prompt is good. I mean, I gave it the script. I think my variable names are decent here. And I think the instructions are pretty good too. Like it's using the colors now. That's some good progress. My game isn't. So it gave me two. So let's see. This is. I want to make sure it didn't like. Added this. Hmm. Okay. Well, no, there's no school. It's not drawing the square. It's a shame. Um, I have a feeling. Yeah, it is drawing, but it's right at the edge. You can't see. So it actually needs. We basically need this to be. Okay, but now it's. So let's see. I think. Okay, it's not. I guess wonderful. There you go. Hmm. Cool. This is pretty neat. I think Grok did a good job. He didn't think through the graphic, but I think he did a good job. I mean, this is solid here. This is really, really cool. So we have a visual, and now now we do the part where we try to run a bunch of trials, count them up. Okay, so hmm, Okay, this is gonna be really slow at first, but after this we're gonna optimize. By the way, the one viewer that joined, you gotta see this. Look at this. So I hit enter, and then it runs the trial again. And it just basically picks, like it knows which side is closest, and it draws a line, and then it draws the perpendicular bisector, and it says if there's a solution. Or so like here is a solution. Pretty neat, in my opinion. Yeah. So now I'm coding the computational part of it, where we actually run it a bunch of times and we see how often there's a solution. How often. So okay. So it's hovering around. This is interesting. Okay, let's count. This is Windows 11. Okay, maybe it is. Maybe it is around. Interesting. That's very interesting that it's hovering around 50. I'm I'm quite surprised by that because I feel like that's not. So the variability is very high. We're gonna try 1,000. We're gonna try 1 mil. 0.5. Okay. So getting better and better. I want to see like at what point is it gonna start taking to, and at that point I want to try multi-threading. But let's see. Um, million. So 1 billion. 1 billion times. I might actually try 10 million. 10 million times take. That's our performance with basic. Pretty basic. Now let's try multi-thread. Now let's try multi-thread. So the approach will split trials across multiple threads, log progress at rate. What will be my execute. At 10. Okay. Very slow. I don't know why it's so weird. Definitely than it think. Probably because writing to a is it gonna start? Dude, this was done. This thing is really slow. I'm guessing it's probably the logging writing to file. But Grok did not do a good job at all. Extremely slow. And I don't know, it's rounding the problem. But mine doesn't match. 491. I'm at 4913. I mean this is, yeah, I mean I copied this. 15 million. Well, you'll complain. You'll complain. We're teaching Grok how to multi, because it's basically just it, I mean this like I don't know what this but it's absolute. So I'm just gonna tell it to amend your code. You should try to separate that out. Make so threads are constantly running. They periodically send their updated data to a shared variable. Alternative thread periodically shared variable. So basically, I could write this, but I'm a little too lazy right now to do that. But the idea is you need to have your setup needs to be in a way where you have like one thread, then you have some shared variables, then you have a bunch of your threads, all they're doing, they're running trials. And then once in a while, it will access this variable, add its data, and then go back to run trials. And all of these just periodically do that. and then you can have this thread periodically take this and then output it, save it to a file. That's the basic idea. So let's see. So logs every 10 seconds. Second. Shoot. Computer dot. I'll try. Okay. So first of all, let's I need to monitor the. Where are my? Hold on, hold on. Find where the. I'm just trying to find where my PyCharm project. My progress. Dude, Notepad very Notepad has become so we're getting the we're at 15. All right. Okay. Should be okay. We're at 58 million trials. Should report every 10 seconds. I'm gonna let it run for a bit, and then we can check the performance. Oh, I'll be Alright, I am back. Finished my yerba mate. Very good. So, I mean, this is about 12 million trials per 10 seconds, it looks like. But we're just gonna copy that in. Wow. 0.8 seconds. And it was wow, so we went from 15 seconds to 0.8 seconds. That's an insane difference. That's a very big difference. Sure. Between these multi-threading approaches. And yeah, I mean, it's still running. We're at 299 million. Okay, well, let's ask Grok what it thinks the performance should be. I also want to check my test. We're at Python is only taking 6%. Not that much. I hope it doesn't rewrite the whole script. Not what I was. Put in 1 billion. So we're like 2/5 the way there. Um, 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 um. So it's seconds. Best performance. task manager. Use the task manager. "24 cores. So I could go up to 20. Right? Go up to 20. $400, so we're halfway to a billion. So we're halfway to a billion. And then our performance was 15 seconds and went down to 0.8. Change the script. Now let's try to do 24. Hope this doesn't nuke my computer. I don't see a reason why I would. But yeah, let's. Alright. So I don't know how many we were at. Okay, we're up to 20%. A little bit more. This is what, like 212? Around 12 again. So I feel like it's not gonna be that much of a difference. But let's try. Okay, so it did not improve at all. Which, I mean, I don't know how workers work in Python. This is like my first time doing it. So yeah, I don't know. But maybe did I not like change the non-workers? And there, I know there's also like weird Windows PyCharm stuff where sometimes like Python is just like blocked from using more than a certain amount of resources. So maybe like we're just hitting that, and because of that, we're not getting any improvement. Um, but yeah, why did Grok say it would take like 50? So we're doing a little better than this. Less than a second, 0.8 with 4 work and with 20. Up this. I just want to try one more time to see if maybe I ran it before like changing this. Maybe it was still running. So gonna wait for it to do a couple of trials here. But we're tending towards, what are we? 0.4914. Currently, yeah, it's about the same. 12 million every, so a little under a second. Is my I thought my mic was disconnected. I was like, was I um probably just gonna okay. Any more does. Like at it's doing like oh, I don't think and then 10 seconds later it should log again. So okay, we're at 759 million trials. So 0.4914, that's pretty solid. 0, and then this is this decimal place changing. Very interesting. Getting close to our 1 billion trial goal. Now, I'm pretty sure they didn't want you to solve the problem like this because they said to 10 decimal places, which I mean, we're at a billion trials, almost at a billion trials, and I mean, 1, 2, 3, 4, 5. I would say we have 5 decimal places of accuracy. So we're like 5 5 orders of magnitude off here. Not nearly precise enough. Ask you. This should be 7 to 15 times 7 to 15 times faster in C++, according to Rock. Use NumPy for this. This I think would be very fast. I don't know anything about Numba. I've used NumPy before. So okay, so we vectorize it. We basically we're able to run a ton at the same Hmm. I would. I mean, I think NumPy. Dude, this is getting into the weeds of Oh, we're at 1 billion. Pretty cool. Okay, well let's just try vibe coding. I'm gonna stop. Why is there only 10 PyCharm sometimes? The NumPy. Do I need a I just made a backup. Right? Let's see. Yeah, might need to install. NumPy is installed. Oh my god, my mouse is glitching. So this might actually. I'm at 100% CPU. Holy moly! Dude, this just did 300 million trials. Dude, this is doing 300 million trials in 10 seconds. That is insane, dude. Holy. Dude, that's crazy. That's crazy fast. Oh my god. That's an insane difference. Oh no. No. Our numbers got too big. Okay, we need to stop this. Our numbers got too big. No, they went negative. Not good. Did we even save anything? Okay, we didn't even save once. Holy moly, but in two, I wonder if we should. Mm, we won't. We won't. We don't want to be. We don't want to be doing. Okay, so but let's the performance. Wait, performance. Oh, never mind. Where's our? Script? Wow. So with NP, it is 0.02 seconds with NumPy compared to 0.8 seconds for a million trials. So that is how many times? 31 times faster. But the problem is that we ran out of our number went negative because it got too big. So we need to talk to Grok. So I'm just gonna give him make a new. Grok's done a very good job. But I negative yes negative trial solution corresponds. Yep. So this is what happened. Up. Uh, yeah. So we went we went above this number. We went above 2 billion, and that's a problem because it's a 32. So modify the compute function to use value count. There. Okay, so should work here. Um, so compute is all, and literally, I think the only things we change. Dude, that's insane that that is like such a simple. All right, well, shall we try again? The other thing that happened is we didn't save the value. I'm wondering how often do we every 6? Not too bad. Well, will we try again here? Again. Okay. Let's see. Let's see how fast we go. Dun dun dun. Um and we were my mouse is lagging again. Um wow. 400 400 million trials in 10 seconds. That's insane. Absolutely insane. We have now had more than a billion cases where where our where there's been a solution. Maybe I'll close this. Free up some system resource. I'm at 100% CPU. Python uses 83% of the CPU. Well, 77. But it's going really quick. And then 1, 2. It should have updated. I'm just gonna pause it. I'll give it one more. One more print statement. But I'll give it a couple more just so it saves it, because it saves it once every 6. I wish there was a way to like save it whenever you exit. Um, but there isn't right now. We can also copy paste these. Okay. So what are we? We're 49140, 49140. That's one. Well, no, even that. We're at 4914. So are four decimal places are staying the same, and then after that is just not good for. I think it's been up that. And JSON. Wow. Is that right? Yeah. So we didn't save. I think this is the one. Yeah, that's well, first let's run our performance just to see how fast we're doing. gonna replace this. Wow. 0.03. Very, very fast. Very, very fast. Okay. And then what was I? Oh, yeah, I want this. Script. Okay. Add a text safe program. Dude, this is crazy. Like, all these tools are just right. You can just use them. You don't have to. You just ask. Like, there's a tool for what you need. It's insane. Below the multi functions. Gonna right. So let's run. I hope it's not any slower because of atext. Atext add exit. I did not read that right. Okay, add exit is what. But so let me just check. I think it's maybe that because maybe if I press like this and then this again, it doesn't save. Like okay, if I press, is that like what is happening? I clicked stop and it. Huh. And if I click stop again, don't. Yeah, it's the same number. So, why is it not? Execute function when a program. Why is it running? Oh, no, a wrong grok thread. When PyCharm is process bypassing by PyCharm. No, I don't like. Me gusta. I don't like because when you start having like try except, that means like if it's in the middle of running here, I don't know when it's gonna hit here. Kind of weird. Let's make grok. Um, a more appropriate. Where is it? Leaders press. Launch a light. Okay, maybe we should start using GitHub here. I was doing this in PyCharm, but I probably wanna move this to Git repo. Have branches and like back up working. Let me new repository. And then create repository. Gonna so probably need to close. All right, let me move all the files. First, I kind of need this. So I have beside the point. Beside the point. Um, there you go. Beside the point, compute beside. What is C? We're gonna rename. Let's rename this. We don't need beside. Okay, and then we have compute beside. And this is what is. Well, I just want to see what the. Wait, let me just copy. And then we have visual. That's all the files we have. Of item. We have beside the. 'Should have. Um. 13. Renamed one. Which one did compute? I think compute same as. Yeah. Or the same. Okay. So have we have beside the point. So this was our first script. Just has the try. And then delete this. We have beside point. have compute at the point, which I forgot the difference. Can do this here and then click. So the first one doesn't use threading. Okay, yeah, I remember. This is what Grok initially gave me when I told it to multi-thread, and then this is what happened when I told him how to multi-thread. So, so we'll just call this Grok compute. Grok compute. Okay. Then we have is the numpy. Full Grok compute Grok. And then parse performance. Yep. Okay. And then we have, okay, very nice. So what we can do now is, okay. All right. Repository is made. Okay, nice. So we have all our stuff. What else do? Well, we can actually now open this in PyCharm. But yeah, what the reason I wanted to do is here I asked Grok make it you need even less. Okay, so okay, this way it always saves. So but you can copy it, and then we go into our NumPy, then we paste this, click save, and then go here, and it shows you the difference. So remove datext, remove this, and then looks like it moved this into a try again. So we can basically see that it didn't break anything. This is like a good way. And then we also, like, in case it did break anything, you can always go back because we have the git history. You can even, like, a good practice would be to make like let's did one I could make a new branch. Bring my changes to the branch, publish branch. And now we can like safely commit to this branch, and then if we ever need to go back, we can go back to main. But this should be working. So let's see. And then I want to clean this up. So I believe this is performance simple. The PyCharm. Yes. Hmm. Why is it not showing? I feel like it's not showing up because it doesn't. Oh, okay. Okay, nice. Nice. Okay. Okay. Now we have this. I want to. Okay. Yeah. Configure. Need to generate new. We want a venv, and then the base Python 3.11. Cool. And then I think we need to install NumPy and Pygame. Once that creates, let's see if this repo's in our. Yep, all here. Very nice, very solid. Oh, wonder if we need these. There you go. Venvis create. Solid, solid, solid. Okay, now we need to install our packages. The game. NumPy. That is installing. And will it auto update our requirements? I don't know if it will, but what we can do is we can what we can do is we can run this and we can go and then we do is 1 second. Sorry about that. I'm back. So, the be running fine. I'm glitching. I think I literally see. Uh, well, of that, um, wrote that down. Okay. And now I chart. Oh yeah, we were gonna rename. I believe this one was. Oh, this by performance. It was for. Oh no, we didn't have it. It was not. So it was finally. Okay, alright. Put this. Yep. Works. Okay. Man, it's really dark in my. Okay, better. So, okay, so we cleaned this up a bit. We now have our repo. And let's just commit. Well, let me. The one pipe. This one. Rest. Push origin. Very nice. Back to here. Branch to. Okay. So let's run our. And then see if our performance drops because of the exit safety. And here, progress. Cool. Right, well. Okay. And I believe it should be. Yeah, logs every 10 seconds, saves every. Let me. Mm -hmm. Okay, let's ask Grok to. Where was it? Opt. Okay. So we're gonna let Grok about that, guys. Go take a break while that's happening, and then we'll see what it comes with. Righty tighty. Back. Let's see what Grok came up with here. Use a thread. Oh my god, this is. Oh, why did it make a Windows specific? I'm gonna turn off things. Let's take. See, this seems like a very basic thing to add, but everything just gets more complicated. That's how coding always works. So we need code imports. Remove the comments. This is the annoying thing with like vibe coding is it'll just like remove stuff that doesn't need to be removed. Gonna so stop it. Okay, that doesn't bad. If it works. This is installed. Okay, hasn't crashed. That's a good sign. I'll wait for at least one print statement. Pressing. Okay, let me press Control S. That did nothing. Nope. That is not. Are we not? Like, what's. Why this. Why this is. Oh, wait. Does Control S save to the file but not exit? That. Is that what's happening? Stop event does. Where is stop? Event. Was stop event. No? Hmm. Yeah, this is just not very cool. Had some progress. Mr. Grok. Mr. Grok. Mr. Grok needs to fix not. So it's gonna just. You removed all the comments again. This is the thing with AI. It just does stuff. Just removes comments. I'm gonna know what I'm gonna. That is unacceptable. So alright, let's try again. Okay, keeping the comments. I don't know why I have to say keep the comments. This is probably why people use Cursor. I've tried Cursor, but I haven't tried it like enough to get the hang of it. Um, but let's see. Okay. Looks fine and dandy. Try this. Okay, definitely running. Wait at least 10 seconds. Press Q. Script. Still not stop. Oh my, oh my. I guess it's waiting for like all the threads to finish up maybe. I mean, it still hasn't saved anything, which is all super wacky. Uh, huh. So it saved once I like stopped it? Okay. Let me try that again. So if I run it again, we wait 10 seconds for some output. Okay, and now we hit Q. Q key detected, stopping script. And then if I stop, oh, okay. So that is, I, mm, I'm gonna try, I wanna make sure you can, it's like runnable like this. I do Python, no, something like that. Hmm. I hit Q, up. Oh, look, it updated, but it's still running. I can, that's a spam control. Hmm, interesting. So, I just wanna, like, I wanna make sure we're not like, okay, that's still about this. So yeah, the save on exit is not working. Hmm. Well, it probably has something to do with the setting, but I think I'm just going to copy this progress file, bring it to main. I'm just gonna not accept. I make sure bring my changes. Um, we don't really need this. I think I'm just gonna tweak it. Saves like every 10 seconds. I just want to see. Let us 5, 6, 7, 8, and it should. Why has it not? This is weird. This should have updated the progress dot. Wait. Oh, we have. Okay. Well, I'll give it a minute, just in a minute. Okay, didn't update. Because it's passing it to logger thread. So this is the default, but um, so now it should. I wanna see the performance is any worse because we're saving every 10 seconds of saving every 60 seconds, which I don't think it should be worse. The saving is happening in its own thread. So it should be independent of like all the other threads running, doing actual work. Which so this should have saved. Dude, this is, you guys don't understand, but my mouse is okay. So I'm naming this one about it. Yeah, that doesn't seem like we're fine. What I'll do, what I also want to do is try to see if I run it outside PyCharm, what the speed is like. So let's try, but first I want to change this 20. Just make it. Okay. Delete that. So let's run this here. Okay, Python. And then we'll wait like a minute just to see what the performance is like. My guess is it's probably gonna be about the same. Task Manager is saying this is at 50. So actually PyCharm I think yeah, but I mean this is like a little under 200 million. And I think we were doing 300 million or so. So PyCharm actually, but not I'm not completely sure of that yet. I'll let it run a little longer. Can definitely know. That should be. Yeah. So almost twice as interesting. This is slower. So I guess whoa, that's weird. In my my progress. I probably spammed control times. Um, but I'll. All right, so I think I'll run this here. It should save after 20 seconds. Might be like maybe like waits the next. My GitHub desktop. In okay, there you go. I think my hub desktop. Okay, should be saving every 20 seconds now. Which yeah, I mean, what are we looking at here? 0.4914 0 1 2. I think we're at around 5 decimal places of precision, because the sixth one is changing. Sixth one is changing. That's just how it is. Yeah. So I don't know if we'll ever get to 10 decimal places of precision, because that's what they require in the problem, is 10 decimal places for the exact answer. So this might just be not that easy to brute force. Oh well, run 15 billion opt, because that's the limit that's set here. Wait, hold on. Why is progress dodge? Is it because I had it open? Should be 7 billion. Ah, dude, that's whack. It didn't save a single time. Oh, dude, is it this? Okay, so I think we can't have it open in Visual Studio because otherwise there are problems, big problems. But yeah, like that's the thing. You can't have like two things writing to the same file at the same time. Um, we're back at 12 billion. It's it kind of reminds me of Cookie Clicker because we're just like waiting for our numbers to go up. Yeah, I mean, not bad, not bad. I wonder like what what amount of trials you would get 10 decimal. Like if you guys have any ideas, definitely let me know. Like I just don't really know. I mean, because it's like five orders of magnitude, which I, I have no clue. This is like some like weird number or like complexity problem. Dude, oh my god. Visual Studio is messing with. They like revert the changes because they don't kidding me. Not good. I was like, how's that small? Yeah, just so make sure to like commit your before opening them in Visual. Hey, what do we think? I mean, I think I'll just let this run like overnight. And Oh, what? Up desktop? Read this. Wait a second. Oh, look, there's numbers. The numbers aren't changed. Did we hit 64 bit your limit? No, we're using Q. Oh, okay. So Grok is like gaslighting me with things that aren't. Because this script was like working fine, so I don't think it can be any of that. I think it's like very specific to the fact that we are like at a large number. Like something is just not incrementing anymore for some reason. Just remove. very sus. Any solution? Farming truck. I'm wondering if it's like the JSON, whatever is like reading, like, no, this will read correct. Hmm. We need to kick out these changes. Hmm. Right. Well, I think I'm gonna call it a day soon, but I just want to see. Issue experiencing. Hmm. This is like, by the way, I need a. I don't remember committing it to not working. Oh. Hmm. Oh, it's still safe. Need. I wish I could just leave this and run it. pretty, pretty ready to go to the gym now. Yeah, it's not It's for some reason it don't go B. Alright. Well, anyways, so yeah, I mean, I think we made some good progress. Still want to figure out how to like keep running more trials on this. We get about 300 million trials per second, right? 0.032 seconds per million. So per second, that is, I guess, 33 million. I thought we were at 300 million. Never mind, I guess we're at 33 million per. Oh, it was 300. Yeah, it was 300 million per 10. The output is once every 10. And yeah, so right now we're sitting at what are we at? We're at this 0.491. Yep. All right. Well, thanks for watching, everybody. So hope to see you again like tomorrow or the next time.